here's our table of contents, and we are adding slope, rate of change, and make sure you are gluing in these pages. Take your time at home to make sure they're all glued in. That way we don't need to waste time in class gluing papers in. So just to remember, this is not written down in our notes, but remember that a rate is a ratio between two related quantities in different units. Like when you say 6 miles for every 2 hours, or 6 miles per 2 hours. Normally, we simplify these to be a unit rate to have a denominator of 1. So it simplifies down to, and we just say 3 miles per hour, or 3 miles per 1 hour. So it's a ratio, usually written as a fraction, where we have a numerator and denominator. We're going to be dealing with these today, and this should be review from sometime in 6th grade. And then we have different slopes that you may have learned about last year. And there's this fun and exciting video called Slope Dude. Now, I think if I play through this, you won't be able to hear the sound, so I did put the link in there. So make sure, I hope you've already watched it, Slope Dude. It's hilarious. Okay. At least for me it is. But basically, to summarize, a positive slope, if we are walking left to right, is like going up in our positives, right? Negative would be like going down. 0 is just walking, right? This is 0 fun. This is 0 fun. And then undefined is like, whoa, just falling right off. There's nothing really to go right or left. So undefined lines are vertical lines. We don't want those. But usually we'll have positive slopes and negative slopes, occasionally 0 slopes. Now, so let's start with a graph, and this should be on your notes page. That's what we're filling in. When we find the rate of change from a graph, we start with a lattice point. So right, a point where it crosses. Oh, there you go. It told you exactly what that is. And then from one lattice point to the next, we count how far we have to go up or down and how far we have to go right or left. So that's our rise over our run, which is our slope. So here we go. We start with a lattice point. Any is fine. I'm going to pick this one. Okay. So this lattice point here, if I'm going to go to this one over here to the right, I have to count how far I need to go up so that I'm on the same level as that point. So I actually went up 1. And since I went up, it's a positive 1. Okay. And then from there, I'm going to have to scooch over. So I'm going to have to run 1, 2, 3 spaces. So I ran towards my positives 3 spaces. So I went up 1 over 3. And then check it again, because that is the slope. You could stop there. But look, to get from this point to that point, we go up a positive 1 and over towards our right 1, 2, 3 spaces. It's a consistent slope. So no matter where we go from any point to any point, we will still get 1 to 3, even from this one. Now, some students will be like, okay, Miss Ezra, what if we go from this point all the way to that point? Okay, well, it's still going to be the same fraction, right? We go up 1, 2, 3. And then if we go over 1, 2, 3, 4, 5, 6, 7, 8, 9, right? That ratio gives us the same thing, all right? So what do you mean? Okay, here we go. If I have that, my rise over run, my positive 3 over positive 9, we still get a simplified form of that, right? Because we always simplify our fractions, which is all these little ones. So the closer dots you don't have to simplify. Up 1, and then we went over 3. So it's all the same ratio. You can go from the biggest to furthest points, but really just stick to the close one. That way, 1/3 is our slope. Up 1 over 3, up 1 over 3. That is our answer. For this one, we have to find the lattice points. So look very closely to see where that line crosses. Oh, I see one there, I think. And I think I see one there. Okay, so we have 3 this time. Now we can always consult Slope Dude. Our last one was positive, right? Because it's a puff, puff, positive. Puff, puff, positive. Working its way up. This one, shwoo, that's a nice negative. So if you know that right now, you know your answer for your slope is going to be negative. So you can put that if you want. But if we move from this lattice point to this lattice point, we move down this time. And if we are going down 2 spaces, that's represented with a -2. Okay. From there, to get over to our point, we're moving to the right one. I did not color code that correctly. 1, 2, 3, 4, 5. That's a +5. So we know our slope right there. It's our change in y, right? Our vertical distance. Our rise, and some of you are like, but don't we have to go up? Well, it's a -2, so it's the up or down version. And then we ran to our right, which was a +5. Simplified. That is our slope, -2/5. We're going to get a lot of fractions for our slopes. That's okay. Again, we go down 2, which is our -2, if you missed it the first time. And over 5, which would be 2/5. All right, you can try the third one here and then check back to see how you did. All right, first we look for lattice points. Oh man. Oh, I think there's one there. Oh, I think there's one there. I think there's one there. Okay, I found him. I think there would be one there too if we continued. All right, from any point to any other point. I'm going to start with this happy face and go to this one. Okay, so I have to go up 1, 2. All right, so that is a +2. And then I'm going to go over to my right 1, 2, 3 spaces. Okay, so it is a 2/3 here. We get a +2/3. So our slope is a +2/3, and that is the answer for our slope. Let me know if you have any questions, comments, or concerns. Because now we're moving on, finding a slope from a table. There's the delta I was talking about earlier. So our change in y over our change in, okay, that's missing. If it's not on your paper, x is the denominator. Oh, you have it on your paper. Cool. So we just put our change in y over our change in x and simplify if we need to. Now, the weird part about the table is that the y is second, but it's our numerator. So a lot of students will flip-flop them. Don't do that, okay? So if we know that our y is here, we want our change in y first. So how do we get from 2 to 3? Well, we add 1. How do we get from 3 to 4? Well, we add 1. 4 to 5, we add 1. So our numerator is a +1. Same thing for our x value. That just goes into the denominator because that would be our change in x. So how do we get from 2 to 5? Well, we add 3. How do we get from 5 to 8? Well, we add 3. How do we get from 8 to 11? We add 3. There's our slope from a table. That's it. You just look for your change in y over your change in x. Tough part is making sure your y is your numerator. Let's try the next one. So notice the weird part, y is in the numerator, but y is down here when we make tables. Why? It's weird that way. So here we go, our change in y, here we go, would be +3. Oh my gosh, +4. Man, okay. +4. And then we add 4. Okay, we get the picture, right? So our numerator is 4. Now we need to figure out our denominator, which is our change in x. So if we are looking at our x values, we go from -2 to -3. We're getting more into the negatives. -2 minus 1 is -3. And we minus another one, and we minus another one. So that'd be 4 over -1. You could leave it like that, but usually we don't write the 1th. You can divide there. 4 divided by a -1 leaves us with a -4 slope. Whole numbers can be slopes too. We just don't usually use decimals too often. For this one here, All right, we want our change in y over our change in x. So we will start with our y, which is right here. And that is our numerator, right, up on the top. So our change here is, plus 3 again, right, plus 3, plus 3. I'm not going to write it again and again and again. I think we got the hang of that. And then we look at our denominator, which is our change in x. All right, so how do we get from 5 to 5? Well, we don't add anything. That would be a plus 0, plus 0, plus 0. So 0 is our denominator. Ooh. Those of you who remember from, I don't know, last week, I think it was, when you divide something by 0, it doesn't work. It's what we call undefined. So that right there, if our slope is undefined, we know our line looks like this. Not a function, undefined, but hey, there's our slope, undefined. All right. So now that we've done it from tables, we've done from graphs. Now, if we have 2 points, this formula is gonna show up a lot. And pieces of it are on my mask, my social distance mask, because it's kind of partially related to our distance formula. And so look for that next time I wear it. Maybe I'll try to wear it next week. All right, so we can substitute in our values for our variables, which is still our change in y, right? The difference in our y over the difference in our x's. It's the same idea. We just have our formula here. So this is a good one to memorize. M is equal to y2 minus y1 over x2 minus x1. Now, what do those ones mean? What do the y means? Let's look at it. Here we go. So we have ordered pair A and ordered pair B. And we know that we have an x coordinate, right, is our first term. And we know our y coordinates are our second terms. We know this. Now, see how there's a 1 and a 2? We have a first ordered pair and a second ordered pair. Honestly, it doesn't matter which one you label which, as long as you keep it consistent. I like to do the first ordered pair is the first one. Second ordered pair is the second one. That way we stay consistent. So there's my x1 and my y1, because this is my first ordered pair. All right, which means this is my x2 and my y2, which is my second ordered pair. From there, we just substitute into our formula. And you may want to rewrite the formula each time. That way it helps you to memorize it, because this is a good one to memorize. It pops up quite often. So we have our y2 minus y1 over x. Let me color code for you. Our slope is our y2 minus y1 over our x2 minus x1. So now it's kind of a matching game. The toughest part is students mix things up or they miss the minus in the formula. So those are the 2 big errors here. So what we have here is our y2 goes first. So I always know this, my patterns. I start from the end, subtract from the same thing. It works in my mind. So we start with this y2, which is -1. Minus is in the formula. The minus is in the formula because then we have this y1 over here, which is a -2. Be careful. A lot of students will just put 1 sign, but we have to make sure we have the minus in the formula and a negative with our 2. So watch out for that. Then we take our x's. So we have our x2, which is 3, minus our x1, which is 4. Good to go. And then we just simplify to find our answer. I'm going to move my face. There we go. We know we have a double negative here. Negative and a negative makes a positive. So we have a -1 plus 2 gives us 1. And 3 minus 4 gives us a -1. Okay, and then we can divide that. 1 divided by -1 gives us a -1 slope. So that's a nice negative. Nice negative. See, right now you can already start to almost visualize your line. Beautiful. Let's try it again. All right, so again, labeling helps until we get those patterns going. That way you kind of know what's happening. So I would suggest label your x and y values, label your first ordered pair, your second ordered pair before you begin. but the more you do it, the better you'll get. So we always want our y2 minus our y1. So we're going to have our -2. Then we have our minus from the formula, 1, over. Then we do our x's. We always take our second x. So we have our 3 minus 5. All right, so we have our change in our x's. Change in our y's over our change in our x's. Then we simplify, which gives us a -2 minus 1 gives us a -3. And 3 minus 5 gives us a -2, so watch out for your integers. Because a negative divided by a negative does in fact make it positive. So we'd have a positive 3/2. Now I know some of you are tempted to write 1 1/2. Leave it as 3/2 because when we go to graph, we want to go up 3 and then over 2. So it's already ready to go for graphing. Leave it as is. All right, try this one, pause it, try it, come back, see how you did. All right, so this time I'm going to go rogue and go without the labels. If you need them, write them. Look back at the previous one if you need help. All right, so we're going to take our y2, 4, minus our y1, 4, over our x2 minus, be careful, our x1. So there is a minus from our formula, and there is a minus from our -2. Be careful. From here we simplify. All right, so we have 4 minus 4 is 0. 3 minus a -2 is the same as adding 2. So we have 0 divided by 5. Now this we can do. 0 can be in the numerator. 0 divided by 5 is 0. So our slope is, this is 0 fun. This is 0 fun. We can right now imagine we have a horizontal line somewhere. Where? We don't know. Well, it's at 4, actually. We could actually know that. All right, so now this is the easiest. We've saved the best for last. Finding slope or rate of change from an equation. All we have to do is get it into this format, y equals mx plus b, and that term with the x is our slope. Ta-da, that's it. So whatever number is there is our slope. Why is slope m and not s? I don't know, maybe s was already used for square. M, on the poster in my room, it says m is like our movement. So when we move, rise over run, that might help you. So again, our goal is to get it into the slope-intercept form. How do we do that? Solve for y with our literal equation skills. We know this. We've done this. So we can subtract 2x from both sides, hence why we did a practice problem like that on the worksheet a few moments, the other day. So we end up with 5y is equal to, now be careful, which one do we put first? If we want our x term first, we want that -2x first, then plus 15. Now some of you might be like, it's -2, it's -2. Not yet. Y has to be alone. Okay, so to get y alone, right, we're finishing solving for y. We got to divide both sides by 5. That way we are left with y equals, okay, we make it into a fraction, -2. This is when we split and divide. We talked about this already. So both of these terms need to be divided by 5. So we have a -2 divided by 5x. And we can do this division in our heads. 15 divided by 5 leaves us with a positive 3. Well, look, it's in slope-intercept form. What is our slope? Oh, bam, -2/5. So if you were wondering what our slope is, it is -2/5. Done. Let me know if you have any questions. We're going to do the next 2 here. Here we go. So we have to get y by itself. So we're going to subtract x from both sides. That way we are left with -2y is equal to -x goes first plus 12. From here we can divide everything by that -2, which leaves us with y equals, now remember there's that secret 1 there, so it's like we have a -1/2 x, and 12 divided by 2 is 6. Now, we don't even need to divide to get that 6. Because our slope is this right here. This is what we want. This is what we need to know is what our slope is, which is a -1/2. So it's a nice negative. Nice negative. All right, here we go. I think this is the final one in your notes. So when we have this, we need to still get y alone. So we can add 3x to both sides. That way we are left with 2y is equal to 3x minus 8. Divide both sides by 2, which leaves us with y is equal to 3/2 x minus 4. Because -8 divided by 2 is a -4. But our slope is this 3/2. That's what we are looking for.